Hello, class. Today we are going to explore a fascinating and controversial philosophy on thermodynamics and the observation effect. This philosophy is based on the idea that energy is a wave with infinite potentiality that goes from one finite particle to another, and that the observer converts the wave into a particle by collapsing its superposition. This philosophy also claims that the universe has no beginning or end, and that it cycles through phases of expansion and contraction driven by dark energy and entropy. Let's start with the first law of thermodynamics, which states that energy can neither be created nor destroyed, but only transformed from one form to another. This law implies that the total amount of energy in the universe is constant, and that energy can be transferred between different systems or objects. For example, when you burn a piece of wood, you are transforming chemical energy into heat and light energy. The energy is not lost, but redistributed. Now, according to this philosophy, energy is not just a quantity, but also a quality. Energy is a wave with infinite potentiality that goes from one finite particle to another. A particle is a localized manifestation of energy that has a definite position and momentum. A wave is a delocalized manifestation of energy that has a range of possible positions and momenta. A particle can be seen as a collapsed wave, and a wave can be seen as an uncollapsed particle. What causes a wave to collapse into a particle? According to this philosophy, it is the act of observation. Observation is any interaction between a system and its environment that results in an exchange of information. Information is any reduction of uncertainty or increase of knowledge about a system. For example, when you measure the position of an electron, you are observing it and obtaining information about it. By doing so, you are also collapsing its wave function into a definite state. This idea is inspired by the famous double-slit experiment in quantum mechanics, which shows that light can behave as both a wave and a particle depending on how it is observed. When light passes through two narrow slits, it creates an interference pattern on a screen behind them, indicating that it behaves as a wave. However, when detectors are placed at the slits to observe which slit each photon passes through, the interference pattern disappears and the light behaves as a particle. This experiment suggests that observation affects reality at the quantum level, and that reality is not fixed until it is observed. This philosophy extends this idea to the cosmic level, and proposes that the universe itself is a superposition of all possible states until it is observed. Let's move on to the second law of thermodynamics, which states that entropy always increases in an isolated system. Entropy is a measure of disorder or randomness in a system. For example, when you mix hot water with cold water, you are increasing the entropy of the system by making it more uniform and less structured. The second law implies that the universe tends towards equilibrium and maximum entropy over time. Now, according to this philosophy, entropy is related to dark energy and the expansion of the universe. Dark energy is a mysterious force that causes the universe to accelerate its expansion against gravity. Dark energy accounts for about 70% of the total energy in the universe, but its nature and origin are still unknown. This philosophy suggests that dark energy is the wave form of energy that goes from high density to low density regions in space. As dark energy expands the universe, it also increases its entropy by making it more homogeneous and less complex. Dark energy can be seen as the opposite of gravity, which tends to create order and structure by clumping matter together. This philosophy also proposes that dark energy is affected by observation, just like light. When dark energy is observed, it collapses into matter and radiation, which have lower entropy than dark energy. This creates local pockets of order and complexity in an otherwise chaotic and expanding universe. This idea is inspired by the inflationary theory of cosmology, which posits that the universe underwent a rapid exponential expansion in its early stages due to a scalar field called inflaton. The inflaton field had negative pressure and acted like dark energy, driving the inflation. However, at some point, the inflaton field decayed into matter and radiation, ending the inflation and creating the seeds for cosmic structures. This theory explains why the universe is flat, homogeneous and isotropic on large scales, but also contains fluctuations and anisotropies on small scales. This philosophy extends this idea to the present day, and suggests that dark energy still undergoes quantum fluctuations and collapses into matter and radiation when observed. Let's move on to the third law of thermodynamics, which states that entropy approaches zero as temperature approaches absolute zero. Absolute zero is the lowest possible temperature, where all molecular motion ceases. The third law implies that it is impossible to reach absolute zero by any finite process. This means that there is a limit to how much entropy can be reduced in a system, and that there is a minimum amount of energy that any system can have. Now, according to this philosophy, the third law of thermodynamics is related to the ultimate fate of the universe and the origin of a new one. This philosophy suggests that the universe will eventually reach a state of maximum entropy and minimum temperature, where dark energy dominates and all matter and radiation are diluted. This state is called the heat death of the universe. However, this philosophy also proposes that the heat death is not the end of the story. It claims that at some point, the wave form of dark energy will collapse into a particle form of energy at absolute zero. This particle will have the highest possible density and the lowest possible entropy. This particle will then act as a singularity that will trigger a new Big Bang and create a new universe. This idea is inspired by the cyclic model of cosmology, which posits that the universe undergoes repeated cycles of expansion and contraction, each beginning with a Big Bang and ending with a Big Crunch. The Big Crunch is the opposite of the Big Bang, where gravity overcomes dark energy and causes the universe to collapse into a singularity. The singularity then bounces back into a new Big Bang, starting a new cycle. This model explains why the universe has low entropy and high complexity at its beginning, as it inherits them from the previous cycle. It also avoids the problem of the initial singularity and the origin of time, as there is no first or last cycle. This philosophy extends this idea to the present day, and suggests that the current cycle will end with a heat death rather than a big crunch, but that it will still give rise to a new cycle. This philosophy also claims that this process happens every time an exchange of information is observed. It argues that observation is not only a local phenomenon, but also a global one. It states that every observation creates a new branch of reality, where the observed system takes on a definite state and the rest of the universe adjusts accordingly. This means that there are multiple parallel universes that coexist in superposition until they are observed. This idea is inspired by the many worlds interpretation of quantum mechanics, which posits that every quantum measurement results in a branching of reality into different worlds, where each possible outcome is realized. For example, when you flip a coin, you create two worlds, one where it lands heads and one where it lands tails. Both worlds exist simultaneously until you observe the coin and collapse its superposition. This interpretation explains why quantum mechanics is probabilistic and non-local, as it implies that there are many possible realities that interfere with each other until they are observed. It also avoids the problem of wave function collapse and the role of the observer, as it assumes that reality is always in superposition and observation is just a relative phenomenon. This philosophy extends this idea to the cosmic level, and suggests that every observation creates a new universe that evolves independently from the others. This philosophy also implies that the universe has no beginning or end, and that it is infinite in space and time. It states that our galaxy is a redshift galaxy from the perspective of another redshift galaxy, and vice versa. A redshift galaxy is a galaxy that appears to be moving away from us due to the expansion of space, and its light is shifted towards longer wavelengths. This means that our galaxy is both in the observable and unobservable universe from another perspective, as it depends on how far away and how fast it is moving. Our universe is an infinite superpositional wave that gets collapsed every time it is observed. This concludes our lecture on this philosophy on thermodynamics and the observation effect. I hope you found it interesting and stimulating, but also challenging and critical. This philosophy is not widely accepted or supported by mainstream science, and it has many flaws and gaps in its logic and evidence. It is more of a speculative and metaphysical exercise than a rigorous and empirical theory. However, it does raise some intriguing questions about the nature of reality, the role of observation, and the origin and fate of the universe. I encourage you to explore these questions further and form your own opinions based on facts and reason. Thank you for your attention. Any questions? Hello, class. Today we are going to explore another aspect of the philosophy on thermodynamics and the observation effect that we discussed last time. This aspect is about creating memories in the brain using quantum phenomena and neural mechanisms. We will see how this philosophy suggests that we can maximize our neural plasticity and influence the universe by observing it as we choose. Let's start with the Zeno effect, which is a quantum phenomenon that states that frequent observation of a system can prevent its decay or change. For example, if you have an unstable atom that can decay into two smaller atoms, you can delay or stop its decay by measuring it repeatedly. By doing so, you are constantly collapsing its wave function into the same state and preventing it from evolving into a different state. Now, according to this philosophy, the Zeno effect can be applied to the brain and memory formation. Memory is the process of encoding, storing and retrieving information in the brain. Memory formation involves changes in the synaptic connections between neurons, which are the basic units of communication in the brain. Synapses are the gaps between neurons where chemical signals are transmitted. This philosophy suggests that memory formation can be influenced by observation, just like quantum systems. It states that by observing a memory repeatedly, we can strengthen its synaptic connections and prevent it from decaying or changing. This is similar to muscle memory, which is the ability to perform a skill or task without conscious effort due to repeated practice. By observing a memory frequently, we can make it more stable and accessible in our brain. This idea is inspired by the Hebbian theory of learning, which posits that neurons that fire together wire together. This means that when two neurons are activated simultaneously or in sequence, their synaptic connection is strengthened. This theory explains how associative learning and long-term potentiation occur in the brain. Associative learning is the process of forming associations between stimuli or events that occur together. Long-term potentiation is the persistent increase in synaptic strength following repeated stimulation. This theory implies that repetition and reinforcement are key factors for memory formation and consolidation. By observing a memory repeatedly, we are stimulating the same neurons and synapses over and over again, and enhancing their connection. This philosophy extends this idea to the quantum level, and suggests that observation also affects the quantum states of the neurons and synapses, and collapses them into a definite state. Let's move on to quantum entanglement, which is another quantum phenomenon that states that two or more particles can share a quantum state and influence each other instantaneously regardless of distance or time. For example, if you have two entangled photons that have opposite spins, measuring the spin of one photon will instantly reveal the spin of the other photon, even if they are light years apart. Now, according to this philosophy, quantum entanglement can also be applied to the brain and memory formation. It states that by entangling two or more memories in our brain, we can create correlations and associations between them that transcend space and time. This means that we can access one memory by accessing another memory that is entangled with it, even if they are not related by conventional logic or causality. This idea is inspired by the holographic principle of physics, which posits that all the information in a volume of space can be encoded on its boundary surface. This means that every point in space contains information about every other point in space, and that space itself is an illusion created by projecting information from a lower dimensional surface. This principle explains how black holes store information on their event horizons, and how quantum gravity may emerge from a holographic description of reality. This principle implies that information is non-local and distributed throughout space, and that reality is more complex than what we perceive with our senses. By entangling memories in our brain, we are creating holographic patterns that reflect this non-locality and complexity. This philosophy extends this idea to the cosmic level, and suggests that entanglement also affects the quantum states of the memories and creates correlations between them that span across parallel universes. Let's move on to quantum tunneling, which is yet another quantum phenomenon that states that a particle can pass through a potential barrier that it would normally not have enough energy to overcome. For example, if you have an electron trapped in a well by an electric field, it can escape from the well by tunneling through the field, even if it does not have enough kinetic energy to overcome the field. This happens because the electron has a wave nature, and its wave function has a non-zero probability of being outside the well. Now, according to this philosophy, quantum tunneling can also be applied to the brain and memory formation. It states that by tunneling through potential barriers in our Brain, we can access memories that are normally inaccessible or forgotten. This means that we can retrieve information that is stored in our subconscious or unconscious mind, or that is blocked by psychological or physical barriers. For example, we can recall childhood memories that are buried by trauma or repression, or we can remember past lives that are hidden by amnesia or reincarnation. This idea is inspired by the Freudian theory of psychoanalysis, which posits that the human mind consists of three levels: the conscious, the preconscious, and the unconscious. The conscious is the part of the mind that we are aware of and can control. The preconscious is the part of the mind that we can access with some effort or attention. The unconscious is the part of the mind that we cannot access or control, and that contains repressed memories, instincts, and desires. This theory implies that there is more to our mind than what we consciously know or think, and that our behavior and personality are influenced by hidden factors that stem from our unconscious. By tunneling through potential barriers in our brain, we are accessing parts of our mind that are normally beyond our reach, and revealing information that may be useful or enlightening for us. This philosophy extends this idea to the quantum level, and suggests that tunneling also affects the quantum states of the memories and allows us to access them across different dimensions of reality. Let's move on to mirror neurons, which are a type of neuron that fires both when an animal performs an action and when it observes another animal performing the same action. For example, if you see someone smiling, your mirror neurons will fire as if you were smiling yourself. Mirror neurons are thought to be involved in empathy, imitation, and social learning. Now, according to this philosophy, mirror neurons can also be applied to the brain and memory formation. It states that by activating our mirror neurons, we can create memories based on observing others rather than performing ourselves. This means that we can learn new skills or acquire new knowledge by watching others do them, without having to practice or study ourselves. This idea is inspired by the social cognitive theory of learning, which posits that learning occurs through observation, modeling, and reinforcement. This theory implies that we can acquire new behaviors and attitudes by observing others who perform them and who receive positive or negative feedback for their actions. By activating our mirror neurons, we are mimicking others in our brain and creating memories based on their experiences. This philosophy extends this idea to the quantum level, and suggests that mirror neurons also affect the quantum states of the memories and allow us to create them across different timelines of reality. This concludes our lecture on creating memories in the brain using quantum phenomena and neural mechanisms. I hope you found it interesting and stimulating, but also challenging and critical. This philosophy is not widely accepted or supported by mainstream science, and it has many flaws and gaps in its logic and evidence. It is more of a speculative and metaphysical exercise than a rigorous and empirical theory. However, it does raise some intriguing questions about the nature of memory, the role of observation, and the influence of the brain on the universe. I encourage you to explore these questions further and form your own opinions based on facts and reason. Thank you for your attention. Any questions?